Imagine a time in the 1950s when computers were akin to calculators, capable of running only one program at a time. It was during this era that the foundations for modern operating systems were laid. In 1956, General Motors created the first operating system to run a single IBM mainframe computer, the IBM 704. This marked the beginning of an era of evolution and innovation. As the decades passed, computers began to include more software programs, sometimes referred to as libraries. These libraries formed the basis of today's operating systems. IBM was the first computer manufacturer to take the leap, developing operating systems and distributing them in its computers in the 1960s. The late 1960s saw the development of the Online System, NLS, by the Stanford Research Institute. This was the first operating system to resemble the desktop operating systems we use today. The 1980s brought about a significant development when Microsoft acquired QDOS and rebranded it as MS-DOS. Unix, a joint effort of the Massachusetts Institute of Technology, AT&T Bell Labs, and General Electric, came into existence in the mid-1960s, initially named Multics. It stands for Multiplexed Operating and Computing System. The FreeBSD project at Berkeley gave birth to another Unix derivative, FreeBSD, which forms the basis of all modern Macintosh computers. Microsoft released Windows 95, a consumer-oriented graphical user interface-based operating system built on top of MS-DOS on August 24, 1995. This was part of its Windows 9X family of operating systems. In 1991, Sun Microsystems developed Solaris, a proprietary Unix operating system. After Oracle acquired Sun in 2010, it was renamed Oracle Solaris. Understanding operating systems is crucial for aspiring computer programmers. It provides insight into how data is saved in the disk, how different processes are created and scheduled to run by the CPU, and how to interact with different I/O devices and ports. Various low-level concepts help a programmer design and develop scalable software. Without a solid understanding of operating system concepts, one can't be considered a proficient computer applications software developer. Furthermore, it's unlikely for someone to become a system software developer without in-depth knowledge of operating systems. If you're a fresh graduate applying for a job at a standard company like Google, Microsoft, Amazon, or IBM, it's very likely that you'll be asked questions related to operating system concepts. In conclusion, operating systems form the backbone of computer technology. From the initial days of the IBM 704 to the sophisticated systems of today, operating systems have come a long way. They play a crucial role in managing processes, I/O devices, files, and networks, among other tasks. So whether you're a student or a professional, understanding operating systems is a key step in your journey through the world of computer science.